Section in Unit 5. This is Learning Target 5C, which is all about parallel and perpendicular lines. By the end of this lesson, you will be able to write an equation of a line in point-slope form that passes through a given point and is parallel to a given equation. You'll also be able to write an equation of a line in point-slope form that passes through a given point and is perpendicular to the given equation. And lastly, we will talk about how to determine whether a set of equations are parallel, perpendicular, or neither. So let's start with the definition of what a parallel line is. So parallel lines are lines that never intersect. So when I have two lines that are parallel, it means they would never intersect each other. Non-vertical lines are parallel if they have the same slope and different y-intercepts. So when we're looking at their equations, then parallel lines happen when they have the same slope but different y-intercepts. And then vertical lines are parallel if they have different y-intercepts. The reason we have to have different y-intercepts here is because if they have the same slope and the same y-intercept, then they're actually the same line, and parallel lines should be two different lines that we're comparing. But they are two different lines with the same slope but then different y-intercepts. Let's look at some examples. So y equals 1/2 x plus 1 and y equals 1/2 x minus 3 are parallel lines. And the reason they're parallel here is because they have the same slope and different y-intercepts. So what are their slopes then? So if we're going to have the same slope, what would the slope of each one of those lines be? So each one of these lines is, remember, in what we call slope-intercept form. So way back in the beginning of learning Target 5C, we talked about what slope-intersect form is, and that is y equals mx plus b. So these are both in that equation mx plus b. What that tells me then is that m is my slope, and that my y-intercept is going to be 0, b. So on this first equation, we have a slope of 1/2 and a y-intercept of 0, 1. So in our first equation, my slope is equal to 1/2. And on my second equation, we also have a slope of 1/2. So in this case, we have the same slopes. They're both equal to 1/2, but we have different y-intercepts. In that first equation, there we go. In our first equation, our y-intercept is going to be 0, 1. And then in our second equation, our y-intercept is 0, -3. So as you can see, for us to be able to talk about parallel and then eventually perpendicular lines, we have to make sure we have all that information down from learning targets 5A and 5B. In this section in particular, we're going to use a lot about slope-intercept form, which is that y equals mx plus b over here. And we're also going to talk and review about point-slope form. So up here at the top, I'm going to add our review about point-slope form, which remember is that y minus y1 equals m times x minus x1, where again m is our slope, and x1, y1 is our point. There we go. And we're going to use both of these in it. So in our first example here, it says write the equation of a line in point-slope form that passes through the point 12, 5 and is parallel to the line y equals 2/3 times x minus 1. So a couple things we want to highlight here. We're going to talk about lines that are parallel. They also want me to write it in point-slope form. So I'm going to start by just writing the general equation for point-slope form. So y minus y1 equals m times the quantity x minus x1. That would be our general point-slope form. They also say that the line is passing through the point 12, 5. So they've given us quite a bit of information here. Remember, to write an equation in point-slope form, I need a slope and I need a point. Well, they already gave me the point directly, so they told me it's passing through the point 12, 5. So I'm going to go ahead and fill that in then. So I get y minus 5, since my 5 is my y1, equals the slope we're still finding. then I have x minus 12 for my x1 value. To find that missing slope, this is where the second part of this information will come in handy. They're telling me that this line is parallel to y equals 2/3 x minus 1, and I know that parallel lines have the same slope, which means if I can figure out what the slope of this line is that they gave me, then I can figure out the slope for my new line. So the slope on this line is going to be equal to 2/3, since that is in slope-intercept form. Let me write that a little bit clearer there. There we go, 2/3. And I know that because this is in y equals mx plus b, so that m value right there is my slope. Since the lines are parallel, I know I get the same slope, so in my final answer for my equation of my new line, I'll have 2/3 in place of my slope value. And that will be our final answer for this point slope form line that passes through 12, 5 and is parallel to y equals 2/3 x minus 1. One thing I do want to point out is that the y-intercept in the line that they gave us actually did not help me find this line at all. And the reason being is because parallel lines have different y-intercepts, so I'm never going to use that information. Okay, let's look at example 2. So in example 2, it says, write the equation of a line in point-slope form that passes through the point -3, -1 and is parallel to the line y equals -2x plus 4. Why don't you guys pause the video and try this one on your own first? So for this one, remember we've got point-slope form. It's going through the point -3, -1, and we know that it's parallel to this line. I'm going to start by writing our point-slope form. So y minus y1 equals m times x minus x1. I'm given the point, so I can sub that in directly, so I'll get y minus -1 equals the slope I'm still looking for, then x minus my -3. We can simplify these, and I will in a second, but let's figure out what our slope is next. We know that it is parallel to the line y equals -2x plus 4, and parallel lines mean that I have the same slope. So if I can find the slope of this line, I can find the slope of my new line. So what would the slope be of y equals -2x plus 4? Our slope here would be the -2. Since this line that they gave me is in slope-intercept form, so it's the y equals mx plus b, so my slope is the -2. So simplifying the double negatives here, so I get y plus 1. I can also sub in my slope then to be -2, since it's the same slope. And then I'll simplify the x minus -3, and we end up with our final answer here. And we know we did this correctly because they wanted the equation in point-slope form, which my final answer is in, and it passes through the point -3, -1, and it is parallel to the given line, so it has the same slope. Okay, let's look at what a perpendicular line is. So on the flip side of this, perpendicular lines are lines that form a right angle. So these lines will intersect, but specifically they intersect at a right angle or a 90-degree angle then. Oops, let's make that a little bit clearer. So these lines intersect at a 90-degree angle. One good example of that would be, let's insert a coordinate pair here. So one good example of that could be a coordinate pair. Or not a coordinate pair, I'm sorry, but a coordinate plane. So in a coordinate plane, we have our x and our y axes, and those intersect at 90-degree angles. So this right here is a 90-degree or a right angle. So one example of parallel lines that you guys have seen for a while now is in a coordinate plane, the x and the y axis intersect and form perpendicular lines. So by definition, if we look at it algebraically, two non-vertical lines are perpendicular if the product of their slopes is equal to -1. Or what's going to help us a little bit more is if their slopes are what we call negative reciprocals. Another phrasing for this that you might have heard is instead of the word negative, maybe you've heard the phrase opposite reciprocals, meaning one of them is positive and one of them is negative, which is why if we were to multiply them together, their product would end up being a -1. Other examples is a vertical and a horizontal line are also perpendicular, which we can see by looking at our x and our y axis. Now let's look at two equations. So if I start with y equals 1/2 x minus 1, and I compare that to y equals -2x plus 5, these are perpendicular lines because their slopes here are what we call negative reciprocals. So the slope on our first line is going to be equal to 1/2, since we're in slope-intercept form, and the slope on our second line is going to be equal to -2, because we're also in slope-intercept form. If I look at these two numbers, these are actually what we call negative reciprocals. So the negative part is talking about the fact that one of these is positive and one of them is negative, or they're opposite signs. And then they're reciprocals because I can rewrite 2 as 2/1, and 1/2, if I were to flip it, would give me 2/1. So here, 1/2 and -2 are what we call opposite reciprocals or negative reciprocals. So those two slopes, so that slope and that slope, so our slope of 1/2 and our slope of -2 are what we call negative reciprocals. If I were to check that and see if their product is equal to -1, let's do that on the side. So if I multiply these two, I get 1/2 times -2, sorry, pen is acting up, times -2. Well, when I multiply these, the 2's end up canceling, since that's technically a 2 on top and a 2 on the bottom, and I end up with -1. So that's another way to verify to make sure that we have perpendicular lines, is that their slopes, when I multiply them, should give us a product of -1. Let's look at our first example here. So it says, write the equation of a line in point-slope form that passes through the point -1, 8 and is perpendicular to the line y equals -5x plus 2. So this looks very similar to our first two examples. I'm still dealing with point-slope form. They give me a point that it's passing through. The difference here is that we're now looking to be perpendicular to the line that is given. So let's start with the point-slope form. I know that that means I'm in y minus y1 equals my slope, which we'll find, times x minus x1. I also know what point I need to sub in. So I'm going to sub in those values and I'll get y minus 8 equals, the slope we'll come back to find in a second, times x minus a -1. So right off the bat, we can write down point-slope form, we can substitute in the point that is given, and then the last thing I have to do is figure out what my slope is. Because they're telling me that the line is perpendicular, that means my slopes are not going to be the same anymore. They would be the same if this said parallel, but since we're asked to find the lines that are perpendicular, the slopes are going to be what we call negative reciprocals. So let's calculate our old slope. So for our line that was given, what would the old slope be on that, or what would the slope be of that line? So our old slope here, the slope of the line that's given, is going to be -5. So to find my new slope then, I need to flip the sign. So my new slope is going to be positive then, since my old one was negative. So I've taken care of the opposite portion, and I also need to find the reciprocal. And the reciprocal of 5 is going to be 1/5. So that tells me that my new slope then is going to be positive 1/5. Let's substitute that in and get our final answer. So we get y minus 8 equals positive 1/5 times x plus 1. And that is our final answer in point-slope form of the line that passes through -1, 8 and is perpendicular to y equals -5x plus 2. Why don't you guys pause the video and try example 4 on your own first. So example 4 says write the equation of the line in point-slope form. So I'm still using point-slope form. It passes through the point 2, 4, And the key now is that it's perpendicular to the line y equals 1/3 x minus 1. Right off the bat, I'm going to just write out point slope form because I know I have to have my final answer in it. We also know that we can substitute in the point values. So I'll get y minus 4 equals the slope times x minus 2. Last step, I got to find my slope. Because the lines are perpendicular, that means their slopes are negative reciprocals or opposite reciprocals. So to find my new slope, I first need to calculate what the slope is that's given. So what is that old slope that we have here? So our old slope for this line that they gave us is going to be positive 1/3. That means that my new slope has to be a negative number since I need opposite signs. So I'll have a negative since the given one was positive. And then I need to take the reciprocal. And the reciprocal of 1/3 would be 3/1. So my new slope will be equal to -3. We can substitute that in and get our final answer of y minus 4 equals -3 times x minus 2. So there's our final answer in point slope form that passes through the point 2, 4 and is perpendicular to y equals 1/3 x minus 1. So we've seen in these 4 examples that they're really phrased very similarly. They're asked for point slope form, they give us a point, but the difference is the word, is it going to be parallel or will it be perpendicular? Remember, if they're parallel, they'll have the same slope, like in examples 1 and 2. If they're perpendicular, the slope will be opposite reciprocals, so I need to flip the sign and then also flip the slope there, and so flip our fraction. In our last couple examples here, we're asked to determine if the sets of equations are parallel, perpendicular, or neither, and we want to make sure that we're also explaining our answer. So we need to have some work that is backing it up, and we need to have an explanation as to why we chose that answer. Let's look at question 5. Question 5 says y equals 4/5 x minus 8 and 4y equals -5x plus 12. So we have 2 lines here. I'm going to go ahead and label this. I have my first line and my second line. And we're going to need to compare the information here. So remember, to have parallel lines, I'm looking for the same slope. To have perpendicular lines, I'm looking for slopes that are opposite reciprocals. And for them to be neither would be if I don't get either of the prior two. So if my slopes are not the same, or if they're not opposite reciprocals, then I'm in the case where these lines are neither perpendicular or parallel. So going back to example 5, in our first line, what would the slope be of that first equation there? The y equals 4/5 x minus 8. So our slope in that first line would be positive 4/5. If we look at our second line, I can't find the slope right away because this is not in slope-intercept form, it's not even in standard form, and it's not in point slope form either. So I need to change this equation of 4y equals -5x plus 12, and I'm going to change it to slope-intercept form because it would be really easy to divide through by 4 and isolate the y. But remember, when I divide one side through by 4, I have to divide the entire other side through. Simplifying this down, we get y equals -5/4 times x plus 12 divided by 4 will give us 3. Now that our second equation is in point slope form, we can identify the slope, and our slope for the second line is going to be equal to -5/4. So what our job is to do now is to compare these. So I have a slope of 4/5 and a slope of -5/4. Well, they're definitely not the same number, which means they're not parallel. Now, for perpendicular, they would have to be opposite reciprocals. They're opposite signs because I have one positive and one negative, and their fractions are actually flips of each other. I have 4/5, and then it flips, and I have 5/4. So in this case, I have perpendicular lines. So these are perpendicular lines, but the key is that we need to explain it. And the reason they're perpendicular is that the slopes are negative or opposite reciprocals. Marker, there we go. And we want to make sure that we're explaining this because the problem did say to explain our answer. So to do these, we had to first compute the slope of each one, and then we had to think about them and compare them. In this case, because the slopes are negative reciprocals, then these are going to be perpendicular lines. Let's look at example 6. So in example 6, we have y equals 3/4 x plus 7. So I'm going to call that our line 1. And our second equation is going to be 4x minus 3y equals 9. So the first line is in slope-intercept form. So I can easily identify my slope as being 3 over 4. So my slope for the first line is 3 over 4. For the second line, I'm going to have to do a little bit more work. Right now it's in standard form. So 4x minus 3y equals 9 would be an equation of a line in standard form. I'm going to solve for y to get this line in slope-intercept form so I can easily find my slope. To do that, I'm going to have to subtract 4x. So I get negative 3y equals negative 4x plus 9. Plus 9. Don't know why. There we go. From here, the last thing to do is divide through by negative 3, which means I need to divide every single piece through by negative 3. So I end up with y equals positive 4 over 3 times x minus 3. And it's positive because of the two negatives. Now from here, we can find our slope in our second line, and that slope would be positive 4 over 3. Now our job is to figure out, well, what is the connection between those two slopes? Are they the same? Are they opposite reciprocals, or are they neither? So my first slope is 4 over 3. My second slope is, my first slope is 3 over 4. I keep saying that backwards. So my first slope is 3 over 4, and my second slope is 4 over 3. So what do you guys think? Are these the same slopes? Are they negative reciprocals, or are they neither? In this case, they are actually neither. So they're not the same numbers, so they can't be parallel. And they're not, although they are reciprocals, they are not opposite reciprocals. So in this case, there are neither because they are not the same. And they are not negative reciprocals. So they are not opposite signs or opposite reciprocals. I don't know why this pen is acting up so much. It's very messy. Sorry, the pen is very lacking on here. So in this case, although they are reciprocals of one another, they are not opposite signs, so we cannot say that they're perpendicular. In this case, they are neither. Let's look at example 7. So in example 7, we have 6y equals negative x plus 6, and y equals negative 1 over 6x plus 6. So in our first line here, I actually have to do the work in this problem. So in this first line, I'm going to divide through by 6 to get y by itself. So I'll get y equals negative 1 over 6x plus 1. So what would the slope be of this first line here? Our slope here would be negative 1 over 6. In our second line here, what would the slope be in this second line? This slope would also be negative 1 over 6. So now that I've found the slopes in both lines, my job is to figure out, are the slopes the same? Are they opposite reciprocals, or are they neither of those? What do you guys think? So in this case, I have the same slope. Whoops. I don't know why this tablet is not writing. There we go. This is the same slope. So in this case, these are parallel lines. And our reasoning, we actually wrote first this time by saying that they're the same slope. So our reasoning is right there by saying that we have the same slopes and stating that relation. So in this video, we talked about the difference between parallel lines having the same slope, perpendicular lines having slopes that are negative reciprocals or opposite reciprocals. And we learned how can we write equations of parallel and perpendicular lines, and then given two equations, I can figure out what the slope is on each one and then compare them to see if they're the same slope, if their slopes are negative reciprocals, or if there is no correlation there. And then that will tell me if I have parallel, perpendicular lines, or neither of the two.